Good day, sir. My name is Abdul Gafar Bakarat Barandia from HUMSS 12.1. So today, I will be discussing functions. Function, in mathematics, an expression rule or law that defines relation between one variable, the independent variable, and another variable, the dependent variable. Functions are ubiquitous in mathematics and are essential for formulating physical relations in the sciences. The modern definition of function was given in 1837 by the German mathematician Peter Dirichlet. If a variable y is so related to a variable x that whenever a numerical value is assigned to the x, there is a rule according to which a unique value of y is determined, then y is said to be function of the independent variable x. The relation is commonly symbolized as y is equal to f of x, which is said f of x, and y and x are related such that every x there is a unique value of y, that is, f of x cannot have more than one value for the same x. To use the language of set theory, a function relates an element x to an element f of x in other set. The set of values of x is called the domain of the function, and the set of values of x generated by the values in the domain is called the range of the function. In addition to f of x, other abbreviated symbols such as g, x, and px are often used to represent functions of the independent variable x, especially when the nature of the function is unknown or unspecified. Let's proceed to common functions. Many widely used mathematical formulas are expressions of known functions. For example, the formula for the area of a circle, a is equal to pi r squared, gives the dependent variable a, the area, as a function of the independent variable r, the radius. Functions involving more than two variables, called multivariable or multivariate functions, also are common in mathematics, as can be seen in the formula for the area of a triangle. A is equal to BH2, which defines A as a function of both B base and edge height. In these examples, physical constraints force the independent variables to be positive numbers, when the independent variables are also allowed to take on negative values. Thus, any real number, the functions are known as real valued functions. So let's proceed to the complex functions. Practical applications of functions whose variable are complex number are not so easy to illustrate, but they are nevertheless very extensive. They occur, for example, in electrical engineering and aerodynamics. If the complex variable is represented in the form of z is equal to x plus iy, where is I is the imaginary unit, the square root of 1, and x and y are real variables, it is possible to split the complex function into real and imaginary parts. F times z is equal to p times x and y plus iq times x of x and y. Point in the complex plane. Unlike real numbers, which can be located by a single sign, positive or negative, number along a number line, complex number required a plane with two axes. One axis for real number component and one axis for the imaginary component. Although the complex plane looks like the ordinary two-dimensional plane where each point is determined by an ordered pair of real numbers, x and y, the point x plus iy is a single number. So that's all for today. Thank you for watching, and I'm very sorry for being late.